Okay, example 2. Our radical looks a little bit different because we don't just have a square root anymore. In example 2, I'm going to do 3 times the 5th root of x plus 1 cubed plus 1 equals 25. And there's a lot of stuff going on here. Okay. The first thing, though, like in our last example, we need to get our radical by itself. And in this case, it's not the square root, but we need to get our 5th root by itself. First thing, let's subtract 1 from each side. Then divide by 3. So 24 divided by 3, we get 8 here. Now what? I don't know about you, but I don't really want to take both sides to the 5th power. We could, but that doesn't really sound like a whole lot of fun. 8 to the 5th power? What we could do instead, we have x plus 1 is to the 3rd power. That's all under our 5th root. Write this as a rational exponent. Remember again, the denominator is our root, and the numerator is our power. To get rid of our 3/5 power, we could take both sides to the 5/3 power. Move my equal sign here so you can see that a little bit better. But take each side to the 5/3 power. The reason we can do that is because if you take a power to a power, remember we've seen before we multiply those exponents? If you multiply something by its reciprocal, we end up getting 1. So that gives me x plus 1 to the 1st power here equals 8 to the 5/3. And then to work with this, the 8 to the 5/3, put that back in radical form. That makes life a little bit easier. It's the cube root of 8 to the 5th. And we could put our 5 underneath, or we could take it to the 5th power like that. This is a little bit easier, especially without a calculator, if you didn't have your power table with you, anything like that. That gives us x plus 1 equals the cube root of 8 is 2 to the 5th power. And 2 to the 5th power is 32. Subtract 1 from both sides. X is 31.